Good afternoon, class. Today we will talk about section 6.4, finding values of a normally distributed random variable. In this section, we will use the properties of the cumulative normal distribution tables in reverse. We sometimes call this the inverse normal distribution. The term inverse normal distribution refers to the method of using a known probability to find the corresponding z critical value in a normal distribution. We will first look at a simple example showing how to do this directly using our cumulative normal distribution tables. What z value has an area of 0.7357 to its left? Notice that our area is bigger than 0.5, which is where the mean lies. Therefore, we know that the z value will be a positive number. It's always nice to be able to picture our problem. So again, we have our number line consisting of our z values, and we have our standard normal distribution. Now, our mean lies at 0, and remember, the area to the left of the mean is half of the area, so it's 0.5. So since this area given is a little bigger than 0.5, our z value is somewhere to the right. And we're asking ourselves, what is this value where the area is 0.7357? To solve this problem, we can scan through the interior of table B, because our z is positive, for an area of 0.7357. So notice that when I look at table B, I find 0.7357 right here. And if I follow it back to a z value, 0.63, I get my answer. So looking at the row and column titles, you will see that z equals 0.63. Now again, pause the video and make sure that you can do this on your own. We can also solve this problem using our calculator, or again, our smartphone app. We first press second and vars. So I'm going to hit second and vars. This is what we used in our previous section. This will access our list of distributions. Remember that we want to keep the TI distributions highlighted. And now we will choose our inverse norm. Notice it says INV norm right below our normal CDF. We finish the command by inputting area to the left, mu, and sigma. So this is how the command works. We're going to input the area given to the left, our mean, mu, and our sigma. So for our problem, we wanted an area to the left of 0.7357. We know that we're using our z distribution, so our mean is 0 and our sigma is 1. And we hit enter, and we get 0.63, as we saw using our statistical table B. Let's look at some word problems involving the inverse normal distribution. At his most recent well-being checkup, Ethan's doctor told him that for his age, his cholesterol level was in a good range at the 60th percentile. Assume cholesterol levels are approximately normally distributed with a mean of 189.1 milligrams per deciliter and a standard deviation of 37.8 milligrams per deciliter for Ethan's age group. What was Ethan's cholesterol level at his last checkup? Now remember that the 60th percentile means that 60% of the data values lie at or below Ethan's cholesterol level. We represent this as an area to the left, right? So notice that our mean, so in this problem, we know that cholesterol levels are approximately normally distributed. So they're represented on a bell-shaped curve. And we have a mean of 189.1 here, right? and 60% lies beyond 50%. So it's going to be to the right of mu. Now this is the x value we want to find. To find our x value, we will first find a z value that corresponds to the picture above. Looking for 0.600600 in the interior of table B, we find the closest value to it. Now, not always are the values given directly in the table, so if that's the case, we want the closest value. And we see that the closest value, we have the options of 0.5987 or 0.6026. Notice that 0.6000 lies between these two numbers. So which one is closer? Well, this one is 0.0026 away, whereas this one is 0.0013 away. So this one is closer. So we're going to choose this value. And it corresponds to 0.25. So it corresponds to the z value, 0.25. Note again here that we can also use our calculator, right? Because this is area to the left. So input this in your calculator with mean 0 and standard deviation 1. This tells us that Ethan's cholesterol level was approximately 0.25 standard deviations above the mean. However, we were asked to find Ethan's cholesterol level. To do so, we will use our formula we acknowledged in the previous section. Remember that if we resolve our standard score formula for x, we get the following formula. X equals z times sigma plus mu. Now, I have my z. We just said it's 0.25. I have my sigma, which was given in the problem, 37.8, and I have my mu, which was given in the problem, 189.1. And this gives us approximately 198.55. We see that our x value of 198.55 is Ethan's cholesterol level. Now, looking at another example, let's assume that lengths of newborn full-term babies in the US are normally distributed with a mean length of 20.0 inches and a standard deviation of 1.2 inches. What is the minimum length that a baby could be and still have a length that is amongst the top 25% of baby lengths? If we want the minimum length for the top 25% of baby lengths, we can simply find the value of the 75th percentile, as shown below. Notice that we want the cutoff point. So in the problem, we know that these lengths of newborn full-term babies are normally distributed. So we can represent them on a bell-shaped curve. And we want the cutoff point for the top 25%. Well, if this is 25%, then that tells us the rest, the area to the left, is 75%. We once again can use our table B or our graphing calculator to see that z equals 0.67. Now, you give this a try and make sure that you get this value. If not, please email me or post in our discussion board. This tells us that the minimum value is 0.67 standard deviations away from the mean. However, this is not the minimum length. To find our minimum length, we again use our formula. So we have our z value, 0.67. Our sigma was given in our problem as 1.2. And our mean, mu, was given in our problem as 20.0. So calculating this, we see that the minimum length for the cutoff is 20.8 inches. Some notes if you are using the cumulative normal distribution tables to find the value z. Not all values will show up exactly in the table. When this happens, we use the following process. So first, we find the closest value to our desired value. Now, if the two values are the same distance from our desired value, take the average of those z values. So add them and divide by 2.